Let me explain about hydrocarbons. Because most of the chemicals are used as solvents. So we have to know the basics of hydrocarbons first of all. This can be classified into two: aliphatic hydrocarbon, aromatic hydrocarbon. Hydrocarbon means carbon and hydrogen are present. Aliphatic hydrocarbon, we can start with, this can further be classified into three, simply speaking: alkane, alkenes, alkynes. So these alkanes, we are going to use this alkane as a solvents, some of the gases also. For example, we start with CH4. Its general formula is CnH2n plus 2. I am not going to discuss about the alkenes and the alkynes. So let me focus only on alkenes. So methane, if there is one carbon, 2 into 1 plus 2, 4. So CH4 is the molecular formula of methane. It's a gas. It's highly inflammable. Then we have C2, 2 into 2, 4 plus 2, 6. So C2H6. This is ethane. And C3H, 2 3s are 6 plus 2, 8. This is propane. C4H10, because 4 2s are 8 plus 2, 10. This is butane. Likewise, it goes. In fact, with the increase of carbon atoms, they behave differently. It consists of one carbon atom. This is two carbon atoms, and it has three carbon atoms. This one has four carbon atoms. And if we proceed further, that is C5 to C7, they act as solvent. And in fact, this range is called light petrol. Light petrol, also used as fuel. And the motor fuel is having C6H11, C6 to C11. So this is the petrol, and this is used for fuel. So with the increase of carbon atoms, it results in wax, a solid state. It starts from gas and becomes liquid, and with the increase like a C18H22 or C16H, C20, this range is used in lubrication oil. Lubrication oil. And paraffin wax ranges from C20 to C30. So this is wax. And after that, you are able to get coal tar or asphalt, that is C30, C40. C30, C40. In this range, you will have tar product. So one thing is clear. So with the increase of the carbon atoms, the boiling range also increases. Are you able to understand? Here, for methane, the boiling point is minus 161 degrees Celsius. It means it catches fire readily and it is in the gaseous state. Its boiling point is much less than the room temperature, because the room temperature is around 30 to 33 degrees Celsius. And that is why it exists as gas and it can easily catch fire. And this butane, this is used in domestic purpose, and this is the domestic fuel, gas. We call it gas, Indian gas, Bharat gas, etc. So this is the gas used in the fuel. This is also gas. So with the increase of carbon atom, what happens here? The boiling point increases. And with the combination of this mixture of C5 to C7, it will not exactly a single point as boiling point. Instead, it will have a range, because it consists of a mixture of solvents. So starting from, for example, C5 to C7, in this range, the boiling point ranges from 20 to 100 degrees Celsius. Are you able to follow? So in the case of lubricant, you know very well, lubricant is almost oily. It is not at all evaporating. Okay, this is all having about 300 degrees centigrade. And in the range of kerosene, so the kerosene actually they come under in this range like gas oil, C13 to C18, like that. So likewise, with the increase of carbon atom, the boiling range increases. So this is as far as aliphatic hydrocarbons are concerned. Then when we look at this aromatic we can start with benzene. C6H6 is benzene. It will have a structure like this. Alternative double bond will be there. So C6H6, benzene, ENE. And if you have got one methyl group, then it is called toluene. That is, this is also aromatic. This is toluene. And this one is called xylene. If it is in the ortho position, it's called orthoxylene. Orthoxylene. If it is a para position, it's called paraxylene. CH3, CH3. Usually we have the mixture of xylene. So the xylene mixture will contain both ortho and para. Okay. And toluenes, xylenes, these are all used as aromatic solvents in paint industries. And these are the major aromatic solvents. And we have some ketones also. For example, CH3, COCH3. This is called acetone. This is coming under ketone. And we have another ketone also, that is MIBK. It means methyl isobutyl ketone. This is also an excellent solvent in paint industry. Methyl means CH3. Then you have got CO group, and then isobutyl. Isobutyl means a C. There will be 4 carbon atom. CH3, CH3, CH2, CH. This is isobutyl group. And this part is methyl. So it is called methyl isobutyl ketone. And this part is called ketone. And we have ethers also. CH3, O, instead of CO, you have only O. So these are called ethers. We have got variety of ethers. This is dimethyl ether. Similarly, you have C2H5, O, C2H5. These are all fast evaporating ethers. This is diethyl ether. This is dimethyl ether. Okay, and we have alcohols also. So the alcohols will be having the OH functionality, OH group. So we have CH3OH. This is the methanol or methyl alcohol. Similarly, C2H5OH, and this is ethanol or ethyl alcohol. This is called the spirit. And you have propanol, that is propyl alcohol, C3H7OH. This is called propyl alcohol. You have got the butanol, that is C4H9OH. So this is the solvent frequently asked in resin industries, butanol or butyl alcohol. Okay, and you know something about this isopropyl alcohol, IPA. These are all used in cleaning the plastics. Isopropyl alcohol, propyl alcohol. That is isopropyl means CH3, CH3 and then HOH. So this is known as IPA, the famous compound, famous solvent, is used for cleaning purpose. Okay, so likewise we have different types of solvents, and in all these cases the boiling point, evaporation rate, these two are very, very important besides the specific gravity. I will discuss one by one.